Here we will simply learn about the some primary concept of distance. This is another kind of distance formula that we called cosine distance, and this is totally related to cosine similarity. So before starting the concept of the cosine distance and cosine similarity, let's see what is actually similarity and what is actually distance. Suppose let's take, we have two vectors, x1 lies on here and x2 it lies on here. And now the difference is that the just I'm comparing the two things, similar and the distance, comparing the similarity here and the distance. Okay, so if you just see these things geometrically, so first see the things geometrically, then and converted the geometrical concept with the analytical concept. Okay, so if you just see the distances between x1 and x2, if simple the distance increased, if simple the distance increased, this distance increased, this means what? This means the similarity of these two vectors has decreased. Simply, if we increased the distance, this means our similarity is decreased. Okay, if we decreased the, if we just decrease the distance, means we have, if we just move closer and closer the x2 to x1, this means what? This means we increase the similarity between this. If we just decrease the distance, simply it means we have increased the distance. This thing, both the same, but two different point of view. Okay, but both the same thing. Means actually if you concluded these are two opposite directions. Example, this means opposite. Similarity and distance as lies in opposite direction. Okay, if we increase the distance, then our similarity decreased. If we decreased our distance, then our similarity increased. This is the same thing. Now let's see this thing. Now what is cosine similarity? Okay, so we all know cosine, the minimum value of cosine. So what? Cosine's cos theta. If you just remember cos theta function, if you just remember cos theta functions, this cos theta's value, minimum value is what? -1 and maximum value is 1. Cos theta is lie between -1 to 1. If we just compare this thing in similarity way, so suppose just I am, instead of cos theta, I am using the cos theta between x1 and x2. Okay, x1 and x2. So similar thing is applicable here. Instead of cos similarity between x1 and x2, means that if our cos theta value is that is simple 1, maximum value, cos theta's maximum value is 1. So if our cos similarity value between x1 and x2 means equals to 1, then we can conclude that our x1 and x2 are perfectly similar. This concludes that x1 and x2 are perfectly similar. Okay, perfectly similar. Or otherwise you can conclude, if our cost similarity value between x1 and x2 is equals to -1, this means that our x1 and x2 are perfectly dissimilar. This means that x1 and x2 are perfectly dissimilar. Okay, this is the simple tool. Now I'm now just construct this similarity concept. Here we have to get the two kind of similarity, that one kind of similarity, that is if cos theta take our maximum value, then we can conclude that our two vectors is perfectly similar. If our cos theta value takes the minimum value, then we are conclude that our two vectors are perfectly dissimilar. Now we are just construct a relationship here. So this relationship is such that if our similar value is a maximum, if it is perfectly similar, if two value is perfectly similar, then we are interested to build this distance. Means if it is perfectly similar, then what? If we increase the similarity, then a decreased. So this here our perfectly is perfectly similar. Okay, this means our distance. In such case, we are constructing interest to construct a function. So our distance here will be equals to 0. If it is perfectly similar, then there have no distances. Okay, and here if it is perfectly dissimilar, then we have interest to construct our distance will be, in such cases our distance will be increased. Here let's take our distance, suppose 2. So how to construct now these functions? Suppose let's see, same thing. Suppose now our functions would be like this. So our cosine distance function of x1 and x2 will be like this. 1 minus cosine similarity of x1 and x2. Okay, so simple first. So let's see. So first, if we just taken our x1 and x2 are perfectly similar, just take these situations. So then what will be the value? Cosine similarity is 1, 1 minus 1. So what will be the cosine distance value? So in such cases, our cosine distance will be 0. Cosine distance will be 0 if it is perfectly from this function. And if our this function is perfectly dissimilar, then what? If this is perfectly dissimilar, really I am going to be confused from this value. I am getting this value, I will get. If perfectly dissimilar, what happen in such situations? Then our 1 minus dissimilar value is what? Minus 1. No, minus 1. So in such scenario, our cosine distance value is 2. I think you will see the in distances. If you, or example, if you just draw this picture, it will be like this. Suppose it is our similarity function, is cosine similarity is these functions, and cosine distance function. So 1 minus cosine similarity means 1 minus, if a cosine similarity is value is, suppose let's take this is this line, it is minus 1 and 1, perfectly similar, 1 and minus 1, it is 1 value and it is minus 1. Okay, when it is 1, when 1 then distance is 0, when 1 then distance is 0. Okay, here, and it is minus 1 then distance is, suppose let's take here 2, it is 2 value. So let's take this is our 2, this value is, suppose let's take 2 value. So now if you just example join these 2 point, so this will be, so you can easily see if we increase the value, cosine similarity function, cosine distance is decreased. This is simple. Okay, this kind of function, I think so clear. Now just apply the cosine similarity distance geometrically. Suppose let's draw the picture first. Okay, let's take it is our features 1, it's our feature. So let's take, we have construct two dimensional vector. it is features 1, and let's take here is one vector, it is x1 vector, here is our another vector, that is x2, and now let's join it and take it. Let's take it is x1 vector, let's take this is the x2. Okay, this is the x2 vector. Okay, and the distance between these two vectors, actually Euclidean distance, we have seen this thing in previous lecture. This is the sample d. This is d means what? Here d means our Euclidean distance. And the angle between these two vectors, let's talk, it is so simple. Cosine similarities means nothing, the value of cos theta. Okay, so don't be confused. This distance is actually Euclidean distance, and this cosine cos theta value, the angle between these two thing is actually cosine similarity. So cosine similarity of x1 and x2 is actually nothing, it is the cos theta value. Okay, cos theta means angle. Here theta is equals to angle between x1 and x2. Okay, now let's just increase the concept. Suppose here this is our vector, and what is the cosine, suppose in this case, if you just find the cosine similarity, then the find the cosine distance is not a hard task. By we have seen that this formula, by using simple this formula, we can easily find the cosine distance. Okay, so we can easily find, so don't be confused, don't be worry about cosine distance. Now we want to play with simply cosine similarity, then by just convert this cosine similarity concept to the cosine distance. Okay, now we are just play with cosine similarity. Okay, we have seen the cosine similarity is nothing, simple cos theta. So now let's take, there have another point. Suppose let's take our another point, and it is better if we just then our point will be, let's see here Euclidean. Let's take our another point is like here. Suppose let's take our another point is, suppose that is our x3. Okay, that is our, we are simple increase the distance. Suppose it's just okay. So this is in the same directions of x2, our x3 is also like here. Okay, so now just see this thing. Now see, just draw this thing. Now cosine distance. Now the first calculate the cosine similarity. Then I am calculating cosine similarity of x1 and x2. What? Cos theta. Cosine similarity of x1 and x2 is cos theta. Simple. Angle between this thing is theta. Cos theta. Now cosine similarity of x1 and x3 is what? If you just see the angle between x1 and x3 is 0 degree, means cos 0 degree. Okay, cos 0 is what? 1, because this line lie on the same direction. So here cosine similarity between x1 and x3 is 1. But if you see Because why? Actually cosine similarity of x2, oh, sorry, I am written something mistakes here. X2 and x3, it will be x2 and x3, and x1 and x2 is theta. X2, I think if we just using the same direction, x2 and x1. Okay, I think it is clear, all of you. Now theta of, why? Because theta of x2 and x3 is equal to 0. Because of this you got. But if you see, if you just take this thing is d of 2 3 Euclidean distance of, and if you just take this distance you d of 1 2. Okay, so but Euclidean distance, if you just see the Euclidean distance, that is d1 2 less than d2 3. Easily you can see d1 2 is always less than d2 3. But if you see the Euclidean distance, just cosine similarity, this is the simple Euclidean distance. Okay, and if Euclidean distance is cos theta, then what will be the cosine distance here? So find first cosine distance. So cosine distance of x2 and x3, it will be 1 minus cosine similarity. 1 minus cosine similarity means cosine distance here 1 minus 1 is equals to 0. Okay, but what will be the cosine distance in such cases? Cosine distance of x2 and x1, 1 minus cos theta. Okay, 1 minus cos theta, and we see that here angle is positive. Here angle is positive means cos theta is greater than 0. So this thing not is equal to 0. Okay, this thing not is equals to simply 0. So what we'll get actually? So we get that this implies that our cosine distance of x2 and x1 is greater than cosine distance of x2 and x3. Our Euclidean just see the relationship. Now we just calculate the relationship between Euclidean distance and the cosine distance. But see here from geometrical point, if our Euclidean distance is increased, but our cosine distance is decreased. Just see these situations. This Euclidean distance is greater, but here cosine distance is totally 0, because here Euclidean distance is larger, but here cosine distance is 0. Okay, these things. Now we derive the relationships between cosine distance and Euclidean distance. Then you can, now just if you just see the curve of the cos theta, just see the curve of the cos theta first. Just draw the curve of the cos. Just draw the graph of the cos. Okay, this is okay. Let's see the graph of the cos theta. Suppose let's take it is our 1, and let's take it is our, and it is 0. Here it is pi by 2. Here it is pi. Here it is, let's take 3 pi by 2. Just extend the line first. Suppose let's take it is 2 pi. Just I am taking means if you just consider in radian, and here this thing means degree, it is like in radian. I'm just, if you just consider this in degree thing, it is 90 degree, it is 180 degree, this thing is 270 degree, this is the 360, both the same thing, both are the same thing. So just first draw the cos. You see it is a simple cos theta. Okay, so if theta is 0, then cos theta's value is 1. Is theta is 90 degree, and then cos theta value is 0. Simple cos and cos theta. Just if you just draw this curve will be look like this. Look like this. Now in pi, cos theta is -1. Okay, cos theta is -1 means here, and cos 3 pi by 2 it is 0, and cos 2 pi it is again. This is the simple period of cos theta. So simple, in one period cos theta is look like this kind of. Okay, simple. This is the structure of cos theta. Now just see this thing. Now just compare this thing closely. I think just to see the two things side by side. I think then it will be clear. Now let's draw another picture. It is okay. This thing is. Suppose let's take this thing is our features 1 vector. Let's take it is our features 2 vector. I am comparing these two pictures side by side. Then you can understand the things more clearly. Okay, suppose let's take here we have one point x1. Here we have another point x2. Suppose let's take here we have another point x2. Okay. Now I am simple using this color. This is or orange color, for example, using the cosine similarity, and just first see and just write down the definitions. 1 minus cosine similarity of x1 and x2 is actually cosine distance. X2. Okay. So first let's take our x2 is here. First take I'm just okay, no problem. Suppose let's take our x1 is fixed here. Now we are simply moving the x2 along this plane, along the whole plane. We are moving the plane. So I am just deriving this thing here, angle between x1 and x2. Then we simply find its distance. Then distance we will find the distance. Okay. So first I am using green color to be more precise. Suppose let's take our x1 is here, and if our x2 is simple the same directions of x1, suppose let's take first our x2 is here. Let's take first is. So what will be the angle? So and now what will be the simple cosine similarity? Actually the similar is same thing in the same directions. So both are the same similar. So here cosine similar will be a cosine similarity means cos theta value, which actually cosine similarity if our x2 is here 1 and cosine distance is what? Cosine distance is what here? 0. Okay, here cosine distance is 0. Now we are simple increase this angle here to here. I am just simple moving this point here to here. I am just simple moving this in this direction. Now our x2 is here. Let's take our x2 is here. If our x2 is here in such condition, this one, now our x2 is here. So if we just simply move the, so what will be now the value? So here if you just taken our angle is 90 degree, here angle is 90 degree. So cosine similarity here what? So here our cosine similarity cos 90 degree. Cos 90 degree means what? Cos 90 degree means in 0 degree. So cos 90 means 0. For cosine similarity will be 0. And what will be the cosine distance here? Cosine distance means 1 minus 0 means cosine distance will increase. Okay. So just if you just summarize this thing here, if we increase the angle between 0 to 90 degree, so our distance will be increased from what? 0 to 1. Is 0 to 0 to 1. This is. Now let's see. Now let's see, we are moving this x2 vector in this direction from here to here. Now our x2 vector will be lying on here in this place. So this is simple our x2. Okay. So if you just moving from x2 here to here in this place, in this directions. So now what will be the angle between x1 and x2? X1 is here and x2 is here. So now the angle of the x1 will be 180 degree. So now cos theta value is what? So cos theta means simple cos similarity. So cos similarity value will be now 180 degree means minus 1. So now what will be the cos distance value? Distance value will be 2. Means 1 minus of minus 1 means 2. Cosine distance value will be 2. So if you just see, just conclude this thing, now we have more further here. Actually we have just compare these two things geometrically. We have moved the point x2 more further and further. Here is further, but from here to here more further. So if we just move the angle from 180 degree 90 to 180 degree, our distance will move from 1 to 2. Now the same thing also repeating here. Now I am just moving x2 point now closer and closer to x1, means I am now moving closer to x1. So now here our x2 point. So in this point what will be the angle? 90 90 90 390 to 270. So cos 270 means what? Cos 270 means 0 again. So here our cosine similarity is actually 0 and the cosine distance is actually what? 1 minus 0, this is means 1. The same thing value. The same value is got here. So the same, if you just now here we got 2 to 1. So if we just change the angle from 180 to 270, our distance will change from 2 to 1. Next, last. Now we are moving x2 as closer to as previous, closer to x1. So if we just here the same value will be happen now 1 to 0. Now 270 to 360 for x value 1 to. Okay, I think this thing understand. So if we just see this thing is geometrically, if we just move our point further and further, then our distance value is increased, and if we move this thing closer and closer, then distance value is decreased. Okay, I think now the concept of cosine similarity is clear. Now if you just think the formula of cos theta, just think this formula of cos theta. Just think what is actually cos theta. If you just see cos theta, if this is our in this direction, suppose let's draw this picture again. Suppose this is our x1 point and this is our x2 point. And this is the directions vector of x1, this is directions vector x2, and angle between them is, let's take theta. So now the theta cos theta value will be, the cos theta value will be x1 dot x2 divided by norm of x1 into norm of x2. We have already know the value of cos theta between these 2 points is related to this thing. We have know already this thing. So this thing another in it is n2 norm. This is simple. The L2 norm means Euclidean distance of x1 and x2, L2 norm. Okay. So suppose x1 and x2 are unit vector. Let's take if x1 and x2 are unit vectors, means what? Unit vectors means this length of these two vectors is 1, means norm of x1 and x2 is 1, are unit vector. Means our norm of x1 means L2 norm, we are talking about L2 norm, equals to same as norm of x2 vector, L2 norm is equals to 1. Okay, if we take these two vectors are unit vector, then our cos theta formula will be x1 dot x2. Simple. Here it will taken the 1. This is the simple for a cos theta formula for a simple unit vector. This is the simple. Okay. Now we have want interest to derive the relations between cos theta and cosine similarity and cosine distance and Euclidean distance. Now how to find relations between? We have seen the differences. Totally difference. Our Euclidean distance is increased, but our cosine difference is decreased. Okay, this kind of situations we have seen here. So let's derive the formula between these two distances. Suppose let's take we have taken here two vectors x1 x2. Now we are simple interest to find their distance between x1 minus x2. Suppose let's take we are interest to calculate its square. Okay, so what is means this thing means in a norm vector, in vector notation, square means the multiplications of these two, x1 minus x2 a transpose into x1 minus x2. Just if you just see this geometrically, I think then clear all of you. Okay, suppose let's take x1 is suppose 3-dimensional vector, x11, x12, x13. Let's take, and x2 is simply, I think it will be better. Let's first write down then x2 to x23. Suppose let's take these are our vectors. Now if you just find the difference, just find the differences of these two vectors, find the differences of these two vectors, means x1 minus x2. It's first find the differences. So what will be the difference vector? x11 minus x, component wise differences means that x12 minus x22, x13 minus x23. Okay, this thing. Now we are taking the simple square term. So if you just taken the square term, so what we will have to done here? Actually, if you just taking the square term, just write down. Means sum of the component with square. This thing means square means the, actually if you just consider this is a single vector a, and this is the a1 first component, second component is a2, third component is a3. If you just take the norm of this one, norm of these two means what? It's supposed to consider it's L2 norm. I have to just consider the L2 norm. So if you just consider the L2 norm, this thing means distance from the origins. So if you just consider distance from the origin, so this thing will be what? A1 square plus a2 square plus a3 square. This thing, this thing will be this one. So this simple a square. If you just, or another language, this norm of a square. Okay. So in another thing, if you just am using this thing, if you just calculated a transpose of a transpose of a means what? A transpose a is means what here? Actually a column vector. At the first, if you just remember at the first lecture, I'm just taking a's vector like a column vector. So a transpose 1 will be a row vector, a1, a2, a3, and a is a sample a1, a2, a3. Just if you just multiply these two matrix, you will got this thing. So I think from this perspective, this clear. This norm square means and this transposition, this transpose multiplication of these two vectors. Okay, I think this thing is clear. Just understanding this thing, I am discuss all the things. I think totally all the thing is clear, all of you. Okay, so let's calculate this thing. So if we just calculated this transpose this value and this value, so what we'll get? We'll just suppose we are first calculating multiplying these two things. Simple. Just I am calculating just here first norm of x1 square plus similarly norm of x2 square minus 2 of simple x1 transpose x2. I sample this thing, this from this thing, just same from this thing. Just if you just simple just simplify these two things, you can easily got this. Okay, because simple, because x1 dot x2, x1 and x2 are commutate each other, means x1 and x2 is equals to x2 and x1 because of this simple property. Dot product is commutate each other. Because of this thing, we can easily find this thing. Okay, now here we have seen this thing, just apply the same formula here. For x1 also, this formula is x1 transpose x1. Okay, I think it is not need to apply because simple we have taken x1 and x2 is a unit vector. If this one is a unit vector, if x1 and x2 are unit vector, means x1 on equals to 1. So this thing will be 1 plus 1 minus, now here this thing x1 transpose x2, x1 transpose x2. Simple, if you just write 2 into x1 transpose x2 means, just if you simple see this thing, means x1 dot x2, between dot product of these two things is equals to, here we have seen this thing, dot product between these two things is actually vector dot product, means transpose of multiplications of this vector. So okay, and for a unit vector we have find this thing cos theta is equals to x1 dot x2. Simple, this thing will be 2 plus 2 cos theta, because simple we have applying this formula for a unit vector cos theta is x1 into x2. Okay, sorry, I think it will minus, I think it will be minus. So this thing will be written as, so if we take the 2 as common, that is 1 minus cos theta, and we have seen this thing 1 minus cos theta is nothing, simple, it is the cosine distance. So this thing is actually 2 into cosine distance of x1 and x2. So this is simple, the Euclidean distance. Just if you take the norm here, if you just take the consider the norm 2, okay, if you just consider the norm 2, then this thing is actually Euclidean distance. So therefore we have got that Euclidean distance here. Euclidean square of Euclidean distance means nothing. This is 2 into simple cosine distance of x1 and x2. This is the simple relations between the cosine distance and Euclidean distance. Okay, this is the relations between Euclidean distance and cosine distance. Okay, now I think the all the thing is clear what is actually cosine distance and cosine similarity and how this thing is related to our Euclidean distance. I think every geometrical point of view as well as analytical point of view, both the things is clear all of. I think if you have any doubt, please revisit this lecture again or comment below. Okay, then I am here to help you. Okay, bye.